right, so for part B, the unknown is theta, and let's see what units they want it in. It says up here, how many radians do the blades rotate through during this deceleration? So radian, so I'm going to be using all of my I want my answers to be in radians, and radians per second squared. So we're solving for theta, and I'm going to use the original facts. So I'm going to use, maybe I need to rewrite them. Somebody can tell me them because I'm going to have to go up here. So the final angular velocity was what? What was it up there? 83.7? 83.7. The alpha was negative 42 radians per second squared, and the time was 1.75 seconds. So here are your facts. So the only fact I don't have is the original angular velocity. So step 2 is omega final. I'm sorry. Theta equals, the only one that doesn't have the original angular velocity is omega final t minus 1/2 alpha t squared. So that's your step 2, and it's also your step 3 because there's no algebra to do. The unknown is already by itself. So I just have to plug in the numbers. So in step 4, theta equals omega ft minus 1/2 alpha t squared. So if you set it up like that, it's always good to set up like that. Then I'm just going to put in the numbers. So this is going to be 83.7 radians per second, 1.75 seconds, 1.75 seconds, and then the alpha is negative 42 radians per second squared. So you can see that the second will cancel the second, that's going to be radians, and over here the second squared will cancel the second squared, and we'll have radians there. So we're just adding up a bunch of radians here, and so the final answer came out to be what? I think I had 211. 211 radians. Did you maybe miss a minus sign there?
Yes.
Okay, yeah, because maybe if you subtracted instead of add, you'd get a much smaller number. All right, so there is your answer. Any questions on that?